welcome to our webinar today on the key components of the semantic layer. We have our partner solutions architect, Tony from Cube, to walk us through exactly what a semantic layer does. But before we get started, I just wanted to go over a few quick notes. You can ask us your questions at any time. Just simply enter and click submit. We'll get those answered during our Q&A portion of the webinar. The recording of this webinar will be available on demand right on our events page. So if you miss anything, you can definitely go back and rewatch or see that portion of the webinar. And if you have any feedback, we would love to hear how we did. Simply take the survey. It's located on the right-hand portion of the panel. It's super quick, and we would love to hear your feedback. And what we're discussing today is what is a semantic layer and how does it work? The 4 features of a complete universal semantic layer, why your modern data stack needs a semantic layer, use cases involving the semantic layer, a few demos, and finally Q&A. So without further ado, I'm kicking it off to our speaker, Tony, to chat about Cube's semantic layer. Welcome, Tony.
Awesome. Thanks, Nathan. Yeah, so let's dive right in. So we have just at a high level, what Cube is. Our goal is to power the next generation of data-driven applications as the universal semantic layer. And we want to make that cloud data accessible and consistent to every consumer in the enterprise. We look at those consumers as being data products, so things like embedded analytics, BI tools, and data analysts, your presets, your tableaus, and then AI agents as well to help inform the context for those bots to make good decisions about what data they use. So a bit about the state of the world that we find ourselves in and the problem that we're trying to solve at Cube. Data chaos. So where we have multiple data sources, we have multiple data consumption tools or applications, and we've got our data model, our business logic is kind of scattered everywhere. Our security isn't necessarily in one place. Some tools can access other tools, others can't. And so that's really the goal of Cube, is to go ahead and solve for that data chaos. We'll go into these 4 pillars of the semantic layer as well. So the data modeling is at the core level, or the bottom tier, the first tier that the data is going to pass through, then access control, caching, and then finally APIs. Everything leaves Cube through an API. So we'll start off at data modeling. So the kind of the root of the semantic layer is defining our dimensions and measures, organizing our data into logical structures. We do that at Cube in a code first manner. So everything is under Git source control. We think that that's the best way to ensure that your data model stays consistent and trustworthy, and where you're able to revert if you make a mistake or use Git blame as you need to make sure that that your data model stays healthy. We do that at Cube under either YAML or JavaScript models. So you can use Python and JavaScript to make your models dynamic as well. And we orient our data model into 2 concepts called cubes, which are kind of our underlying logical layer, and then views, which are our presentation layer, where we might organize better collections, more user-friendly collections of our data. So inside those specific topics, or so for example, the cubes, that's going to be where we're defining joins. We're going to be defining our custom dimensions, anything that we want to custom logic, anything that we want to come up with on our own to enhance our business logic. We can code that here in the Cube. And then in the views, we're just concerned with bringing in the right dimensions and measures from the Cube layer, and then presenting those out to our, making those available through APIs to our downstream tools. The second pillar we call access control. So this puts a security context over every request that comes into Cube, no matter which API it's coming through or whether it's cached or not. We want to make sure that the data is going only to the parties that have permission or authorization to see that. So you can create a very robust permissions model or access control layer in either JavaScript or Python. We can make sure that that's set up to support your enterprise or small business use case. We want to make sure that that all that data is leaving secure. But we also provide the flexibility to incorporate external API calls, so you can use systems that are already in place that have these rules or have roles assigned or attributes assigned to users. We can bring those into Cube. So caching is where a lot of folks like to talk about performance, and we're no different. You know, this is the kind of the sexy part of Cube, where we can make slow queries go very fast by pre-aggregating and caching them within Cube's Cube Store layer. So these are defined in code as everything else is. We're able to bring in the measures and dimensions that we deem necessary to that are going to be queried that we want to accelerate. And then through Cube's aggregate aware query logic, it's going to be able to use those pre-aggregations for any applicable queries that come into the front end. So, and finally, APIs, I mentioned earlier, everything leaves Cube through an API. We have a SQL API, a REST API, and a GraphQL API. And no matter which format your query comes in at, it's translated to the underlying SQL of the data source that it's targeting, and that query is run on the data source. The data is brought back and presented in either the SQL or the JSON format or the GraphQL format that you've requested. So CubeX is that the intermediate layer to help keep things consistent, no matter which endpoint you're running through or which application is connected to that endpoint. So we've gone through a little bit about the benefits of a semantic layer. We'll kind of break down the main or the core benefits of the Cube semantic layer, for example. Data consistency, I think, is at the core with those metrics definitions, measures, dimensions, and then the dimensional models that we expose through views. This helps standardize the data handling and make sure that everyone is on the same page. It's basically a single source of truth for data within the organization, no matter which tool you're using. And this can cut down on a lot of time spent trying to hunt down which data source you should connect to for which purpose, or the dreaded hey, why don't our numbers match problem, because we're using data that's older or data that's been snapshotted at a different time or been exported to a different warehouse for analysis. Why doesn't that match our upstream source data? We've got consistency because everything's coming out of one single endpoint. From a security standpoint, the granular dynamic access control is a huge feature that a semantic layer needs. Those row level, column level, object level rules. We want to make sure that our data is secure and handled behind a robust permissions layer. And so we can do that in code with Cube. Our cloud product also has the regulatory compliance certifications for HIPAA, SOC 2, et cetera. So you can be sure that your data on Cube is secure, and want to make sure that it's auditable and traceable as well. So you can set up auditing or logging tools to make sure that you can go back through and prove that your systems were intact in case of an audit. Performance. This one's always a fun one for me. That the caching layer just unlocks a lot of use cases. For example, a dashboard that might take minutes to load off of a source system, whether it's a data warehouse or an OLAP database. It can really inhibit the use of analytics in production. Nobody's going to want to sit around and wait for a couple minutes for a dashboard to load, or even dozens of seconds. What we want to get to with Cube is sub-second query time, and that's going to unlock the big data use cases, or even the small data use cases. It's going to help make sure that those are performant, and that the cost associated to them for those upstream data sources is minimized, because we're able to use the caching layer within Cube. From a flexibility standpoint, the single stack, or the do it all in one application or one platform, it always sounds good, and I always keep looking for that unicorn platform where you can go from source data to all the applications that you want to use in a single tool. But I think the world that we live in, there's always going to be another tool that you want to integrate. There's always going to be another data source that you need, or another front end tool, and so having a stack that's flexible to incorporate additional tools when that fits the business use case is very important. It also reduces your vendor lock-in, so you're not necessarily stuck on a single platform if that's not going to work out for your use case. Time to value is another great piece, another great feature of Cube, because we're able to deliver a lot of the developer tools, things like the APIs, the caching layer. It's all instant with Cube. You just connect to your upstream data source, and figure out what your data model is going to be, which fields are you going to expose, and you've immediately got an acceleration layer. You've got an API to get to that. You can incorporate whatever security rules that you need, and a lot of our customers are saying that they can accelerate their time to release data models, update individual data models, as well as just release new products entirely, and that can make your data engineering team, in the Cloud Academy's case, 5 times more effective. You can do, hit your OKRs 5 times faster, and take on bring a lot more value to the business. And future proofing. So this kind of goes hand in hand with flexibility too, but we're able to integrate other tools, things that come up if you have an AI use case, but you don't have that connectivity back to your data source. You need that middle layer to provide the access and provide it securely. So the flexible and scalable foundation of the semantic layer is very important for that long-term future-proof use cases. So let's talk through a few use cases, according to each of our, ideal use cases at Cube, things that our customers are finding the most value in right now. So we've got data apps, we've got BI tools, and we've got AI agents. And we'll start with the data apps. So like I said, with the APIs that are instantly available, it's just an instant unlock. You connect to your upstream data source, you automatically have a REST API that you can hit with your React app. So it just accelerates your data development, or your application development process, because you can just assume that layer. You don't have to go build that layer from scratch. The pre-aggregations also handle the caching. It's a purpose-built tool for this application, so it's very good at what it does, and there's no need to reinvent that wheel. We've spent hundreds, thousands of dev hours trying to make this fast, and that can save you a lot of time in your within your application as well. And from a costing standpoint, the caching layer is going to insulate you from the upstream data source costs. So if you've got a cloud data warehouse that bills on usage, or per query or per gigabyte, or even per minute. You can set up what you want your refresh, your pre-aggregation refresh cadence to be, and be able to predict what your cost is going to be on the data warehouse. And then from a Cube standpoint, the cost is very transparent and predictable as well. So you're able to provide better estimates for your leadership team. You be a better steward of your budget, and understand where your costs are going to incur and where they're going to go to, that aren't necessarily tied to, oh, we had a big usage spike and now we're out of our budget on the fourth day of the month. So let's take a look at that use case. Go ahead and share up my screen here. Awesome. So here's an example of a React dashboard, and that is in Cube's demo library or example library. So this is all these numbers are coming directly from a Cube instance, which is pointed at an upstream Postgres database. There's a couple tabs on here, one for orders, one for dashboard, and this is something that a lot of developers are familiar with making in React. So we've got this code sample that's up. We've got a number of different examples available in our GitHub repository. And just to show you, for example, the total profit, this number, really all we're doing is grabbing line items.price. So this is our whole query that's driving that number. And then you can see our components within React. Pretty straightforward to build. To build those loops to actually just display the elements that you want. Those go through and they hit the Cube instance. So, for example, the query I just ran a minute or a few seconds ago came through. It actually ran a bunch of queries. So if you've got a data warehouse that's sensitive to concurrency, this might be a problem, but it's not a problem for Cube. So these came through. These aren't. We can see that those aren't cached. And if we run through, let's go refresh it again. Fast again, and then we'll watch the query history populate here real quick. It just comes through super fast. Yeah. And our data model, for example, on that, for our line items, the price, line items.price, that's where we're defining exactly what data is going into this. And this is something that we can share with our BI tool. This is something we can share with our AI agents, or other apps that we're making, both internal and external facing. And we know it's going to be the same number coming from the same cache, following the same security model, because we've defined it, here in our schema. So let's hop back into the slide deck. So the second main use case for self-serve analytics, BI tools, a lot of this is a lot of the benefit that the semantic layer provides is eliminating that many-to-many chaos, where we might define the data model in our data source. We might define the data model in a custom or inside the visualization tools data model. So it's basically locked into that product, and we can't necessarily extract our data model or our any of those definitions to another product. We can't reuse them. We have to recreate them and maintain them in multiple places. And it's kept under, the model's kept under source control in the semantic layer. We're sharing all the cache security and the data model, and no matter which API we're using, it's going to be consistent. And we've also got a feature specific to Cube with the semantic layer sync, and that's going to be where we push the data models into those BI tools. So into your presets, your tableaus, you can have the same data model or whichever data model that you choose pushed into those tools. So we're going to walk through what that looks like. But essentially, a lot of folks are using a dev instance of a BI tool, or maybe they've got one team that likes Tableau, another one that likes Power BI. You can set up your synchronization so that both tools will have the same data, or your dev and your prod will have the same data, so you can do your development in the same environment that you're expecting to deploy to in production. So we'll take a look at what this process looks like. All right, so we have our data model here in Cube. We've got, if you remember back from towards the beginning of the presentation, we talked about how cubes are kind of the logical layer. They're handling things like our joins. And then we've got views, which is more of our presentation layer, which are including the actual fields that we want to expose to those downstream applications. So we have just a few fields that we've pulled out that are ready for prime time, ready for our BI tool. So for example, over in preset, we have a data set that's brought in. So this is our orders view table right here from views. We have the semantic layer sync set up. So all we have to do if we make a change is hit the start sync button, and it's going to push each of our views in here that we have set to be exposed to the API. It's going to push each of those into preset as a data set. So in this case, we're looking at orders view. We've got a few fields here. Let me update the chart. Just refresh our data here. I think it's actually going to wake up our dev instance here. And while that's running, we can look at the query history, see when these requests come in. Yeah, this instance has been off for a while. So it looks like that rolled through. We can update the chart again, just to be sure. There it goes. Okay, so let's say we want to add a measure to each of our downstream BI tools. So over in the data model, we've got in the orders cube, we've calculated this new model called completed percentage. And this is in this scenario, it would be an important metric to track for our leadership team. So we've calculated it here, vetted that the calculation works, it meets our business requirements, and then we can bring it into our orders view. So we'll uncomment that. We need to hop into dev mode to do that. So when we hop into dev mode here in Cube Cloud, it's going to create a copy of the repository and spin that up in a development cluster. So it's dedicated, it's completely isolated from our production, and we can make any changes in here that we need to, test it out in our playground, see how the query performance is, test out pre-aggregations, all before committing and pushing that to our production deployment. So what we'll want to do is, so now we're going to include that completed percentage into our master data model. So commit and push, again, everything's under source control in Cube. So we're able to see we're able to keep track of these changes, and you can go back and harass me about the poor git commit message later as my code reviewer. So in preset, we'll just refresh the page. So we have completed percentage here, as that synchronizes through. So we can bring that out and update our chart. And we've got a brand new metric brought through, straight through to preset. So there's a whole webinar that we did with the preset team on this semantic layer sync product. But I think this is a big component that's going to unlock a lot of productivity for folks using a semantic layer with their BI tool. All right. And then we'll look at one more use case. So our AI agent use case. So a lot of the issues that we're seeing with the AI agents being able to query our data and provide, junior analyst type responses, a lot of those are inhibited by messy data models or, those wonky column names that we have to give to fit into, character limits, and using underscores and abbreviations that the agent doesn't have a lot of context for. So with the semantic layer, we're able to provide all the context that an agent would need. They're very good at understanding what the use case is, when to use each field if you provide a very thorough description for its context. So the semantic layer is a great place to do that. You're defining it in one spot under source control, and then it's accessible for your end users, including the AI agents. We can also tailor the access model for specific agents, so they can, you've got an agent serving the finance team. Well, they don't need access to the HR data, so we're going to make sure that they use a dedicated account that only has access to those resources, for example. And we want to make sure that, with for example, LangChain, we have a document loader integration, and that will allow you to pull in the metadata about your fields directly into the LangChain context, and the bot is able to make better decisions because it knows it has the information around how to use each field that's provided. So a lot of the hallucinations, I think, is the term that we've kind of settled on, where the AI is confidently wrong about something, especially when it comes to our data. We don't want to be confidently wrong about anything. That's going to lead to bad decisions, wasted budget, and poor feedback down the line. So what we want to do is make sure that the context is provided. We're insulating our abbreviated database names, and we're providing all that context. The LLM is connecting to the semantic layer instead of directly to the database, and it's going to make sure that it's using the right field, and it has the context to choose the right field. For example, if we tell it to use SQL to access a database, it's going to marry that SQL information up with the metadata context that we provide through the descriptions and through the titles. So we'll take a quick look at this as well. All right, so for LLMs, we've partnered with a company called Delphi, and they provide a chatbot type support, access to your data model, and they've been a great partner to work with for several months now since they've launched. And we can basically plug in Delphi to Slack, or they've got their own web interface that's outside of Slack as well. I like Slack because I'm in it all day, but we can ask Delphi a number of different questions. What is in the data catalog? We can see what it has access to. You can imagine this being quite long. We've got just a small data model in here for testing purposes, but we've got a view called sales that it has access to. It's got different measures and dimensions that we can query and sort. We can ask it, plain text questions like what are the top 5 companies by AOV. Now, we're not defining AOV anywhere, but we're counting on the LLM to be smart enough to figure out that AOV means average order value. And it sure does. So it gives us the AOV as well as the underlying calculations that it used to get there. We can even see the query that it ran against Cube. And this is using our REST API. So it's showing us exactly what it ran in order to get that result. This is 100% what we need these days for interacting with LLMs from a data standpoint. We need to be able to audit and understand the query that the LLMs are running. Otherwise, we don't know if it's hallucinating. We don't know if it's making up its own calculations or bringing in the wrong field. We need to be able to vet that. So I know Delphi's doing a lot of work to build that trust layer, or at least the transparency for us to be able to use tools like this without having to, be only 70% accurate. It's great when it works, but it only works 70% of the time. We can't rely on that. So we can take these random queries, chart the total sales by year for Austin. It's going to go through, filter those, give us the results. So that's Delphi and the way that we augment those LLMs, chatbots. Let's see. I think that's about it. Just make sure I don't have any more slides here. Yep, we're on to Q&A. So if you've got any questions, go ahead and drop them in the chat. I'll take a look at the Q&A here and see if there's anything so far. So we've got a good question from John. Can you describe when data transformation using a tool such as dbt ends and semantic modeling using a tool like Cube starts? So I like to think of that as a materialization question. So if I need to write things back to my upstream data warehouse, I need to materialize some tables. Maybe I've got JSON documents in Snowflake. I want to parse those out in a tool that's made for transformations, and specifically made specifically for transformations. I can handle that pretty well within a tool called dbt, or a tool like dbt. And then when I'm actually going to present those, use those, that final table or the processed data, then putting that through a semantic layer where I'm defining my measures, my aggregates that are going to need to be more flexible than anything I can materialize on the fly in a materialized layer. Then that's where I'm going to be looking to the semantic layer to finish that modeling and then present that out securely, performantly, and through an accessible API. We've got a question about on-premise deployment. So, how do we do this on-prem? So Cube Cloud has as part of the Enterprise Premier tier, there's a bring your own cloud option. So it's not exactly on-prem. You can't spin it up on your internal data center, but it will run inside your public cloud account, your AWS, your GCP, your Azure. And we can spin up those resources within your own account. So it can get as close to your data as possible if we've got specific security requirements, or if it'd be a huge headache to exfiltrate your data. to even a trusted platform. We understand there's organizations like that that have those rules, so we've got that offering available. A lot of our customers, or most of them, are on a less or on a kube hosted version. There's VPC peering. There's other tiers of multi-tenant options available. So that might not necessarily be the most cost effective or the most applicable to your situation, but we can work with your team if you've got a specific use case. Happy to have that discussion and figure out where it makes sense for Cube to sit.
Cool. I think that's all the questions that we have. Thank you so much for attending today. If you do have any more questions about a semantic layer or even more about Cube, we definitely have more resources for you. So check those out. They're located on the left-hand portion of the panel. And if you're interested in engaging into the conversation, join our Slack community. We have over 88,000 data practitioners there ready to talk. And if you are interested in learning more about Cube, attend one of our upcoming events. We'll have more in August with getting started with Cube Cloud and doing a joint webinar with Metabase. Thanks everybody for attending. Hope to see you soon. Bye.